There we go. So August 31st, that was the end of that month. And by the way, it looks blow away. If you look outside right now, it does not look nice. So good thing you're all in here with me. It's a little scary. Have you been out? Oh, Ben is a little weird. Right. Any questions? Did anybody? So let's see. Well, should we take guesses on how many people went to the thing on Friday? Did anybody here go to the other Ben's Friday session on Java? Oh, 1, 2, 3. Quiz on that day. Somebody had a quiz the first week. That's not a course that I want to take. Yeah, Ben wants to know what course that is as well. Okay, Ben said nobody showed up. I don't know if it was recorded. I will check with Ben when I see him later. How do we know? Just a quick question on groups. How do we know if the group was set up?
They haven't been set up yet.
Oh, they haven't been set up.
I'm still waiting until like the first assignment is closer to the due date.
Yeah, so the first assignment will be announced in 40 minutes,
Sure.
right? And it's going to be due in a week. So please get your phase 1 will unlock right after class, and it will be due soon. So get yourself a partner. We'll talk about that just in a second. And then once you figured out who you want to partner with, email Ben, and the email address is on the
It's on the syllabus.
On the syllabus course website. Yeah. All right. Cool. So any other questions? Oh, the course with the quiz with stats 411. So there are 2 reasons not to take that course.
I served my time.
I don't understand probability theory and statistics. It's way above my head. Still remember the guy who taught me that. He was like a farmer in clogs. I don't understand a word of it. I don't know if it was recorded. We'll check with Ben, and if it is, I'll get him to post something on Yap. Yeah. So probability theory people are a special kind. That's how I take it as well. Anyways, if there are no questions, then what do you mean you haven't gotten Yap to work? What's the problem with getting it to work? Well, have you tried CSC 460 and UNLV like it says in the on the web page and in the handout and everything? So username is CSC 460 and password UNLV. There you go. It's on the course web page, on my web page, isn't it? Yeah. No, it does not say computer science account username. And in okay, when let's see here. Yes, it says please. It says please register on Yab with your computer science username as your username, and then fill in the missing information. You weren't registering; you were just trying to log into it. And if you go to here, share contact. So can you see the web page here with my smiling mug? Please register for Yap, even if you had a profile before. This is a new Yap installation. Please use your CS login as your Yap login. The board is password protected. The username is CS460 and the password is UNLV. And yeah, so it doesn't say so there. I wonder if it says so in here. doesn't. But you're in now, right? And now I'm just going to figure out how to stop sharing this thing here. Why can't I stop sharing? Oh, so I just clicked that one? No. We'll just do it like that. All right, so now you can still see this guy here, right? Anything else? I really want to tell you about this. I've even prepared the stuff. So let's do an example of a small language. And then we saw last time how if you go and look at figure 3.2, which I suppose we can call up here, this guy here, right? So if we can create interface for each of the various keywords or identifiers or literals or operators or separators, then we can create a large NFA with epsilon transitions all the way down there, and that's bound to work and produce the correct token. Now there are some things we glossed over here, and that is, what if some of the strings this guy can generate can also be generated by this guy? Then should we return the token that's represented by this final state, or should we return the token that's represented by that final state? We haven't sorted that out, so we gotta figure that out. But let's just take a quick look at this NFA to DFA business, and the example is the one that's in the book, and let's just do that. So let's say that we have CD, CDD, C plus D star. And let's just say that there's some action associated with this. And that action is typically create a token. That's what a scanner does anyways, right? It creates a stream of tokens. So every time we recognize a token, create a token for the parser and return that. Now, if I look at these, then it should be pretty clear to see that this keyword, if you wish, can be generated by this rule as well. So can this way, because this is one or more C's followed by 0 or more D's. So that can be CD or CDD. So what we need to do is we need to have the more general ones at the bottom, because if I put this one up here, then these will never be taken into account. So when we have our regular expressions for all our possible tokens, we line them up in a list that goes from more specific to more general, right? And let me just ask: Can anybody think of a situation for the for Java, for example, or C or any other language, where I have two different regular expressions for two different things, where one covers the other? Yeah, IDs, exactly. So an ID can generate all the keywords, can't they? Right? I mean, the rules for ID could generate if, or then, or else. There's no then in C or Java, but never mind. It could certainly generate all the keywords. So that's why we need the rule for identifiers to be at the very bottom of our list, at least below all the keywords. Yeah, so that's correct. Right. So what is it they say when you watch the cooking shows? I have prepared this from home, so let's see. Oops. Not that. Here we go. put it up there. So what do we got? C, D, that's that one. C, D, D, that's that one. And here I've just noted that we should generate the token CD for that one, and here we should generate the token CD for this one. Now let's just check that this, the one that comes around here is indeed C plus D. So C plus is at least one C. So we have one C, then we can skip everything and go over here. And then we have D star, we can skip and go down here. If we don't, then we'll go down here and we can produce as many Ds as we want and get out. If we didn't skip after the first C, we can go over here and do as many Cs as we want. So that seems reasonable. We've labeled that one with C plus D star, glued them all together with an epsilon and a common start state. So we have 1, 2, 3 accepting states. Now, how many people remember how to do NFA to CFA? This is what we should do quizzes. You know, we should just let's do a pop quiz and turn this into a DFA, and then people go like, "Oh!" No, this is more fun to do when people are in front of you, because you can see, you know, the absolute devastation. Right? I should have done that in 456. You remember mostly, right? So, with subsets and states and stuff. Please don't write that down. That's just fun. Oh. Yeah, that's exactly how we're going to do it, with substates or states and stuff. Right? I think. I'm sorry. That's just funny. That's a good one. It is something with substates, right? Because it has something to do with creating these new states in the DFA that consists of a subset of the NFA states. And you probably remember that there was something, depending on who you took it with, you know, Larmor or Kowalski, whatever, who said, you know, when you create a DFA from an NFA, you might end up with an exponential number of states, because what are the total number of possible states? Well, that's all possible subsets of states. So here we could have 2 to the 16 different DFA states if we're unlucky, but we're not. So it's all good. And the way we do it, of course, is we say, you know, if I want to figure out what subset state, so maybe I can just squiggle or write a little bit on this here. So what subset state does 0 belong in? Well, it's all about how far can I get without consuming any input. So I'll say, all right, I can get this far. So if I say, all right, my new state, we'll call it S0, and then we'll make a note here that says that S0 is 0, 1, 4, and 8. Now, if I go and look, I can see, well, how can I get out of this state? I can get out of it on a C, on a C, on a C. Right, so we can leave on a C. And we get to S1. Well, S1 then is going to be these. And however far I can get without consuming any input. Well, that's there. It's there. It's all the way over there. It's there, there, and there. So S1 is 2, 5, 9, 10, 12, 13, and 15. I think. 5, 9, 10, 12, 13, 15. Yeah. And what I'm going to do is I'm just going to mark that 15 there, because that's the only accepting state in S1. So if I ever get to S1 and I can't go any further, then I better accept and say that it was that token that I scanned, because indeed it was a single C, nothing, nothing, and I ended up there. And then, of course, you can see, well, okay, what can we do from S1? Well, we can leave on a D, we can leave on a D, we can leave on a C, and so on and so forth. So if we do this for long enough, then we end up with this. And you can see that looks, the beginning is good, right? So S0 on a C to S1, S0 on a C to S1, yeah, right. So we end up with this nice little DFA. Right. So now we have that. What should we do then? This recording thing, I don't know why I can't get rid of that. Move that out of there, maybe. There we go. You want to go back there? Yeah. So what's the next step? Once we've created a DFA, then let's minimize it. And how many people remember how to minimize a DFA? That's even worse, right? It's something with putting all the start states in one set and all the putting all the accepting states in one set and putting all the non-accepting ones in another, and then doing something. So it turns out that this is minimal. That was lucky. So good for us, right? So let me just bring in a table form. Do we need S3? Yes, we need S3. And I will show you why we need S3 right now. So what do we got here? I've got the actual DFA or the NFA states in here, right? So if we look at it, this guy was that first one we had here. So we got that one right. And the second one was that. We got that one right as well. That's this guy here. And look, I have underlined the accepting states. That one there has that. There. Now, there are two states here that are very interesting for a certain value of interesting. And that's the fact that this guy has 3 and 15 in, and this one has 7 and 15. So I think that one is minimal. I really don't want to give it a go right now, but I think I've worked through that it is probably good. And if you just hold on for a second, you'll see why we gotta do the way we do, because the way we're minimizing this is indeed actually not the right. So the original minimization algorithm doesn't care about which accept state you get into. So what you do is you divide all your states into accepting and non-accepting states. When you do minimization of these DFAs, you've got to create more sets of accepting state sets. And in particular, you've got to pick all the ones that have accept state 15 in 1, 7 in 1, and 3 in 1. So we do that because it matters here which accept state we end up in. And you can see that with S3 and S4 here. Because in S3, I could have gotten there by saying C, D. I'm done, right? That's that rule. Now, if this is an accepting state, then I can only accept if I can't continue. So if I have a D on the input, then I'm not allowed to stop there. So C, D, D, which means that I'm never in a situation where I see that CD as an accepted thing there, because scanners are greedy. DFAs are greedy. They always continue consuming as much input as they possibly can before accepting. So what happens here and here? Well, I could have said 1C and 1D in that rule, but that's the same as saying CD in that rule. This one is more specific, this one is more general, this one takes precedence. So if when we line them up from specific, when we line them up from specific to most general, then the specific ones will get lower accept numbers. This one is 7 and this one is 15. So that means I should always accept the one with the lowest number. So here we accept 3, not 15. We can see that there, that's action 1. And here it's 7, not 15, that's this one, and action 2, not 3. So those 3, which is 1, 2, and 5, so 1, 2, 5, those are the ones that we accept C plus D star, C plus D star, and only in state 3 do we do CD, and only in state 4 do we do CDD. So the minimization algorithm is slightly different. But the only difference is the original starting states you start out with. Why are S1 and 2 final accepting states? Well, because is it legal to say just a C? Well, sure. I take one C and no Ds. And 2, you take 2 Cs, no more Cs and no Ds. Well, that's 2 Cs from here, no Ds from there. Yeah? Yes, star is 0 or more, plus is at least 1, so 1, 1. Right, so how do we do this? Let's just see. So the rules for creating these is step 1. Determine the regular expression for each token type. And once we have that, then we can arrange them in order from most specific to least specific. Once we have that, then we can use, I don't know who this Thompson guy is. We can use Thompson's algorithm to create an NFA. That was that one that looks sort of like this. Yeah. Then we can do NFA to DFA. Then we can minimize. Actually, this was 3, 4. This is 5. This is 6. And 5 is NFA to DFA. Oh, yeah, so determine token types for all final states. So that was basically just this business here where we said, well, which one of these shall we pick? We always pick the one with the lowest number. And then finally minimize. Yep. Right. So let's look at how to encode. Oh goodness. Click that one twice. Click that one, and there we go. That one. So what I got here is not what I wanted. Actually, I want. I think I'm just going to grab this guy again and then make it a bit smaller and put it up there. And then we shall take that table and that table, which is a little bit crooked. That's all right. And this one, right? So that first one is the transition table for the DFA, right? So we can see if I'm in state 0 and I see a C, go to 1. State 0 on a C, transition to 1. If I'm in state 0 and I see a D, error. And if I see anything else, throw an error as well. Now, of course, we only have columns for C and D because those are the only two members of the alphabet. If I'm in state S0 on a C, go to 2. State 1, go to 2 on a C. State 1 on D, go to 3. State 1 on a D, go to 3. So I can encode up this this transition table. Now I can also code up what to do in a certain state, whether to accept or not. So for example, if I'm in state 0 and I see a C, transition using that. If I'm in state 0 and I see a D, error. Well, that's the same as that. If I'm in state 1 and I see a C, transition, that's that way. And if you see a 1, transition. If you see anything else, then you're in an accepting state, and you can accept, and you accept 2, which is that one, right? Is that right? Oh no, 2 is just accept. You accept. I don't know what I accept yet. 2, 1 here means transition, -1 is error, and 2 means accept. So we then need to go look in our lookup table to see what to accept. So if I end up in state 1, that's there, and I have to accept state 1, and I have to accept, then it's got to be the token for C plus D star, because that's the only one that just consists of a C. So that's rule number 3. So I can code this up in a number of different tables, and if you think about it hard enough, you can probably find a way to put this into just one table if you want to. It's certainly possible. I've done that, but I didn't make a copy of it, so you can go look that one up. Now let me show you the algorithm. So I broke it down into 2 different things. I have something down here at the bottom, which is just one that does the action stuff for me. So it says, well, in case 1, then the action associated with the first regular expression, etc. So this stuff here is just something that's going to create the appropriate token. This other one here, from here to 21, is the actual business end of it. So we start in state 0, and we haven't read anything. IP is going to be an index into the input. If there's more input, then grab the next thing, which is the look ahead, and then figure out what the index of that look ahead is in my tables, and now go look in my action table. If the action table contains a 2, then that's an accept. So just call this function do action down here. Otherwise, if it's a -1, then we have an error, produce an error message or an error token. Otherwise, change to the state that you get out of transitioning from whatever state you're in on whatever index we calculated. So if we're in state 0, we see a C, that's index 0, transition to 1. So we get a new state, we update our lexeme with what we had, increment the index, or the index counter for the input, and be done with it. And if we ever end up down here, return an NF file token. Now, it might be that we should just make this scanner slightly better, because this is fine. I'm happy with it. Right. So you can see, if you can provide those 3 tables and this function down here, this is super simple, right? Because it works for all possible NFAs to DFAs that are implementing scanners. So that's all there is to it. Now, let's take a look at, unless there are any questions on this. Want to make what bigger? Oh, the whole, okay, I can do that? Why didn't somebody say that? Like that? Hey! Yeah. Why didn't anybody say that? It's because all these young people have good eyes. It's not like me, yeah. Yeah, I didn't actually think of that.
Well,
it's you know what it is? It's because the way we used to do it in 460 was not use WebEx. We used Yes, we did the recording.
Oh yeah, that's right. We did it through.
Well, this is done through there as well, so it's always looked crappy for years. Oh, well, what do you know? I didn't Alex say anything all those years. Don't get me started. Rumors that I need glasses. Hey, we've got a troll. He's even got the right height for one.
Oh, did you record Friday's lectures then?
Yes. All right. Can you post on Yab 460 where to find it, please? I'll take that as a yes. What is the code? What is the token code specific for? What token code? Are we looking at one of these guys? Or that one? What line? I don't understand the question. Maybe unmute yourself and explain it rather than typing for an hour.
Oh yeah, that's a better choice to do.
I think
Uh,
so.
so I was asking, so we have the scanner here for a specific token.
No,
Do
we
we
have a
know
scanner for a specific language.
for a specific language? Okay, and that language is any?
Any one you can create such 3 tables for.
Okay, got it. Okay.
So if you look at this table, the transition table is basically how do I navigate this thing, right? That's the thing that's needed for a regular DFA. But we need a little bit more than just a DFA because we need to produce tokens to the parser, right? So we need these other tables. This one here is basically, you can throw that one away and then you can figure it out just with this guy and this guy, basically, right? Because you can always check for this one, say, oh, if this one says no action, go just do some transition, because you'll see here that there's a almost an overlap of this where it says error there, it says token there, error there, token there. So this is just sort of making it, stating the bloody obvious as to what's going to happen. So the way we transition around this thing, that table, the one that determines whether or not we should transition or accept that table. And if I am going to accept, this is going to tell me what should I accept. And you'll see here that the ones where it says accept here and here are exactly the ones that have tokens in there. So I might as well have taken this part, moved up here and said accept that token, right? So I get an index. That index is just column number here. And then I say, right, does my action table tell me that that I should accept? Choose accept, right? If it does, then call this function down here, who will do the appropriate thing depending on what state we're in.
Got it. Thank you.
Okay, you're good?
Yes, sir.
So I don't need to go any further?
No, I got a gist of it.
All right. Well, yeah. So, and of course, if we shouldn't if we shouldn't create any tokens, and if we haven't broken anything yet, then we're just adding to the string that we've scanned, and we transition to the next state and advance the input by 1 and keep track of what we've seen so far. Right. So now let me pull this one up. So how does that look? Really, I should join from this screen here so I can always see how it looks. That could be confusing. So, here we go. Down here is the Espresso grammar and text format. So this is the grammar that we're going to deal with in the assignment. And it is big because it's pretty much all of Java. So what would you do now if I said go and write a so we can look at this. If I said go write a scanner for Espresso. Well, first of all, you'd have to go find a lot of paper and some sticky tape, and then make a really big sheet of paper, and then hope you didn't make too many mistakes because you're gonna have to start over again, right? Oh, so I just said go write a scanner for espresso. It's probably better you can't see that because it's a daunting task, right? So if I just gave you the knowledge that you have now and said, right, here's the grammar now, buzz off and do that, right? So what are the terminals? We got to go find out what the terminals are because the terminals are the ones that we need to write a scanner for. So if I look at this for a little while, I'll be like, oh, it looks like all the keywords are in single quotes. Look, there. It doesn't take long looking at this to find out that all these things that we need regular expressions for are in single quotes. All the way down, see here, the operators, the assignment operators, the double or, the double and so on and so forth. And then you think about it for a little while, you realize that these guys here and this one here are those pesky ones that are not just simple. So if let me just go back to here. They're the only ones that don't look like, oh, maybe it was from last time. They're the only ones that don't just look like long strings, right? Oops. Because IF, AND, right? So all those and the operators, they're just long strings. It's just the literals and the identifier that are complicated in some way. So writing regular expressions for 99.8% of everything in here is as simple as saying a B goes to an O, goes to an O, goes to an L, goes to an E, goes to an A, goes to an N. B goes to Y to D to E. Right? So that's super simple. This is probably a lot more complicated because what are the rules for Java double literal? Complicated. Identifier, that's probably not too bad. So once you've done, you've extracted all this and you created regular expressions for every single one of these things. You create this thing here, and now comes all the fun because now you have an NFA with 350 states or something like that, and no more. It's yeah, that's what it's. I thought actually it was 650, and then it ends up being 450, or it's way over 500, I think. So you need a real big piece of paper or write really small. Okay, and then you have to minimize it afterwards. Can you do that in a week? No, that's silly. Let's not do that. So we can answer here. Yeah, no. Let's not do that by hand. So what if I then said that I have this piece of magic? Here, I'm going to sell you some magic beads now. I have these two magic boxes, one called JFlex, and one called Java Cup. And I've given you a grammar as well. So you can take that grammar and turn into a specification. So let's just call that spec 1 and spec 2 because they're not the same. Throw that one into JFlex, throw that one into Java Cup, and out here comes a scanner, and out here comes a parser. And trust me, when we get to the parser, that's also going to be a pain if you do that by hand. We're looking at several hundred states as well. So all we got to do is we're going to write the specification for the two, and this specification down here is a list of terminals, a list of non-terminals, and a list of productions. And this thing here is just a list of regular expressions plus their action. Okay? So if we do that right, then that shouldn't take very long. Now you can use this thing here to do some copy pasting if you're careful, but you have to be very careful because there are some funny things that I just want to point out to you. So a production, if I have A goes to little a or epsilon, that becomes A colon equal, and then here goes whatever token, oops,
Professor, we can't see.
Oh, well, that's there we go. Good. Right. So I need a bigger screen. There's sort of a generic rule. Instead of an arrow, we use colon equal. And instead of the terminal, we use whatever name I choose to give it, and that name is named up here. We'll see how it all fits together in a second. What a token name given. I'm just going to use an A, or, and then an epsilon is nothing, and then we have to put a semicolon at the end. All rules end in a semicolon. I like to put in a comment here saying, there's more in the handout. There's more in the handout about that as well. So let's take a quick look at what to do in order to get the assignment. So now I have to share another window. This can only go bad. Right, so, oops. I have a feeling you probably can't read those little letters. Why not? I'm sharing it. Can I see your screen? Oh, I'm sharing two applications. Share content. Can you see those letters? Is that readable? Or do you want bigger?
Yeah, sure.
How's that? Good. So I think you should make yourself a CS460 directory. There you go. And go into it. Now you need to copy a file. If you're working on your machine at home, you need to SCP the file. If you are working on Bobby or Sally or Java, don't use java.cs.unlv if you're going to be doing Java stuff. Then you can just CP it, or you can SCP as well. That's fine. So SCP your username, and that's Matt for me, to Java CS UNLV edu colon tilde Matt / CS. I can never remember if it's CSC 460. CSC 460 espresso U space dot enter. And then it asks for my password. When you do it, it'll ask for your password. Unless you put my username, then it will ask for my password, which you don't know. So there we go. So we got a little file, which is beautiful, beautiful shell script. All right, the first thing you do is you go into it, put your name here. So don't put my name, put your name. Schmodded 755. Now you can execute it. And if I do that, it says, huh?
Yeah, if you want to go.
What's CyberDoc?
It's file transfer. It's some files.
I think that should have been called Cyber Chicken because that's a chicken move, right? Real computer scientists use the command line.
You can. Yeah.
No, Benjamin Softon, tilde mat is good, isn't it? Yeah. Yeah. It worked. Look, I got the file.
Well, yeah, that's because you're running it to your.
No, tilde mat expands to my home directory for everybody. You can try it.
Yeah.
Right, so you got the file there, and we can do some things. We can install a phase number, we can install some tests, we can patch things, and patching things is when I screw things up, so that's never been tried. Espresso U tar is the file that creates the tar file that you have to hand in, and Espresso U is open tells you if a phase is open, so we can say Espresso U is open 1. Type in your password if you can remember it. It's closed. All right. Well, let's see. You just tried and it's asking for my password. Well, it only does if you typed in my name in the Espresso U script. If you put Matt here, then of course it's asking for my name. That's why I specifically said put your name there. Or whatever you log in is, right? All right, let's try this again. It's open. Yay. Espresso U install 1. I'm going to change my password to 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So, done. ls-l. What do we got? Apart from that tilde file, which we'll just get rid of. Then we got a phase 1. Let's go in there and see what we got. We got some directories, include and lib. Don't worry about those. We've got a build script, which is magic. It just tells the Ant build system how to build. I don't know how it does that. It's got in a file called Espresso info, which I bet you just has a single character, a 1 in. It does. It's just to identify that it's a phase 1. Then it has 2 shell scripts. Oops. There's that one and that one. Espresso C will run your compiler, and you can see that it sets some class paths. Then it runs a file called Espresso C. It specifies that include directories include. It says something T token, that just means produce output, that is a list of tokens. Run phase 1 and run whatever file you give it. And if you want to run my output, if you want to run my compiler, then you do that through this curl call to a remote installation that runs my reference compiler. So now we can actually start doing things. So let's write a test file. Public class test int x equals 1. Void foo int y int u int w or int b equals hello times 7. There we go. And then if I say Espresso CR test.java, it's not going to cry. There's nothing wrong with this code. It's perfectly fine. It's syntactically correct, right? So what did we get? Well, it says you can see here all the tokens. Public class identified test curly bracket int x equals 1 semicolon void foo open bracket int u close bracket curly bracket int v semicolon w equals hello multiplied by 7 semicolon double closing bracket. And if we see success down here at the bottom, it means that the compiler did not blow up in your face, and that is always a good thing, right? We always look for success. Now what happens if I try to run it through the newly downloaded compiler? It just says, yeah. Right, so we got to compile the compiler. Now we are going meta, totally. And we compile the compiler by saying ant. We can clean it all up by saying ant clean, like this, and it just nicely cleans it, and then we can just say ant, and then it just builds it for us. And it said, yeah, no, that didn't work. It returned 100, build failed, bad things happened. Okay. So we can see what it says up here. It says, I created some directories that went fine. Then I'm trying to build the scanner, and then I'm going to try to build the parser. And we see here that there was an error here in building the parser. So there are two files that we have to deal with. And if I just look at the directory here, there was my test file. There's the source directory. That's where all the source is. That file is the one that if you don't fill it in correctly, you get 0 points for the phase. So the first thing you do when you download a new phase is fill in id.txt with you and your partner's name, student ID, and preferred email. So that way when we mark them, we can actually figure out where they came from. Right, so let's go into source. Oops. There's a whole bunch of stuff in here. There's something that has to do with code generation. There's the run file, espresso-c. There's something that has to do with still code generation, phase 5, phase 3. There's the parser, there's the scanner, phase 4, and some utility stuff, and then a phase running module directory kind of thing. If we look at espresso-c, there's a whole bunch of stuff in here. And don't mind this line here. You don't have to fiddle with this file at all. This is where you see success. So if we ever get to the end of this file, everything was good. Now this one here will just execute a phase 1 thing, and if I look in phases, phase 1, it just does a parse, and the parse is what drives the scanner. Will this run on WSL? I have no idea what WSL is.
It will.
What is it?
WSL is the same. It's a Linux on Windows, essentially. It's the same thing we're just doing right now. All you need to do for WSL is to install ant, and I'm sure you have Java 8.
Yes.
I think it'll work with any version of Java, but especially make sure you have ant installed.
I think 1.5 and up.
Yeah.
Yep. Right. So let's see. Here's the scanner directory. There is if I hadn't actually done this, then there would be one file in here, and there would be one file in the parser directory. So let's open this one up. This is the one we're going to have to do some work in. That's the specification. And I just stole that from somewhere and yanked out some stuff for you to fill in. And when you go and watch the video, this will be explained as well. So I really don't want to go into much explanation with it now, because you can just sit down and watch the video. But basically, the specification says create a package called scanner that imports these two things. The class that is created should be called scanner. It should be public. It should be 7-bit, and it should pack things up nicely. It's creating a scanner that works with CUP, and it makes available lines and columns. Then there's some Java code here that's used to creating error messages and tokens. This one here is the method that we call to produce a token. You can even see here it says new token based on a kind. And then it comes just a bunch of definitions that are nice to have. They're just regular expressions. It says the line terminator is \r, that's carriage return, or new line, or carriage return new line. And anything else is an input character, so everything except for RNN. Etc., etc., etc. All this stuff we don't have to worry about. And I mean, who would have ever come up with this? It takes a long time to figure this out, so we'll just leave that in there. Then we just list all our keywords, Boolean literals, null literals, separators, etc. here. So wherever it says your code here, you need to fill in. So we'll start with the keywords, abstract, boolean, break. You see, this is the regular expression for the abstract keyword. It's just an A followed by a B followed by an S followed by TRACT. And when I do that, I return a token, which is called abstract. Now this name here, we can kind of define, or we can determine ourselves if we want to. But in order to be in agreement what they should be called, if you go and look in the AST directory, there's a token file that has a long string array. Let's use those names without the double quotes, of course. So if we go and look at there's abstract. So we'll use those, and if we do that, then everything turns out fine. And interestingly, as you can see here, where is the identifier? It's down here somewhere. String literals, character literals, comments, whites. There's identifier. Identifier is the very last thing, right? So if it matches identifier, and where's the rule for identifier? That should be up here somewhere. Then it's just about to die. That doesn't sound good. There, it's just a Java letter followed by a Java letter digit as many times as you want. So this list here is where we have to make sure that we get the most specific ones at the top and the most general ones at the bottom. Right? In here, there's a whole bunch of stuff, but as I said, we list the terminals. We use the same names as we got from that string array, because the names that we use here are the ones that get written to this file named sim, and those are the ones that we use in the scanner. So all we got to do is we got to list the tokens here, and we have to list them in order because order matters, because they get given a number, and that number is used as an index into the array in the token class. So that's why this is important. Just list them in the order that we have in there. Then we list the non-terminals. They can go in any order, but let's just put them in the order they appear in the grammar. And then we just put the grammar in, making sure to use : equal and a semicolon at the end. And then that's all there is to it. Once you put that in, you type ant, and then you test. So of course we need some test files. Espresso. Oh, we got to go back here. Espresso U, install tests. Here. There you go. So now you should have a test directory. Actually, you might want to go in. So if we did it this way, just move that stuff out here. Then we have one for each phase. Look at phase 1. There's some espresso, espresso plus, and espresso star, which is plus plus because we can't use the word star. So if we go into espresso, we'll see there's good tests and bad tests. Let's go into the bad tests, and let's just look at the bottom one there, the wild test. Now what's wrong with this one? It says up here that you can't declare you can't have the keyword int there. So of course it's that thing there. So if you type in your grammar correctly, it should certainly catch that. And if I go to the good test, these are all perfectly fine. So nothing wrong here. They should fly right through. Now, once you've got everything running and working, you can use these tests because these are the tests that we're going to use to mark your assignment. I don't know, Ben, what are we going to do? Are we going to give a file that they can just run that'll tell them what grade they'll get if they hand it in as is? When is that going to be available?
I can get it available this weekend. I can do it tomorrow, Thursday.
Yeah, we might miss it for this phase, I think.
I'll do it phase by phase.
Right, but once you have the first phase, so if we get it for this, we'll strive to have it for 2, 3, 4, 5, and 6 at least. So basically auto marking, where when you run it, you get the same result as what we get. and that basically tells you what is what's the grade you're going to get, right? So that way, if the script comes out and says you get a 0, it doesn't come as a surprise if you get a 0, or even worse, if you get 100, it doesn't come as a surprise, or better, I suppose, that you get a 0, no, 100, right? If your system or if your compiler doesn't compile, we're going to give you a 0. We don't have time with 92 people in the class to muck about with that, unfortunately. So make sure that that something compiles, and then, as we said, you get points based on how many of the files you can run. And it's not that you get more points for the hard ones than you do for the simple ones, because the simple ones, in terms of scanning, parsing, and doing many other things, are just as complicated. Yeah, because there's a bunch of underlying stuff that has to work properly for that to work. So you can basically figure that out yourself. Now, if you go and so normally you don't go to other people's directories, but you have my permission to go to this directory. And in there you will see an Espresso directory. Go to that one. And in here there are a bunch of different things. So we can start by reading the README. So that just tells you what you can't do and what you can't do. Now there's a file here called autogen3.py, which was written by... So autogen3 is... who wrote it? Why can't I remember that? Why didn't he put his name in here? Alex, he's in our class now, isn't he? Or he was 789. It was the other Alex, right? So he's very good. He's very good with Python, and I'm not. But go read what it says in here, and this can actually help you, because it'll run the reference compiler once, save those results, and then it'll just do magic tricks, right? So this is really good for you to automate all your testing. You put down a list of what you want to test, and then you just run it. There's the Espresso U files. That's the one we just downloaded. There are the various directories. You never need to do anything with that, because that gets done by your Espresso U, so don't muck about there. Then I have this thing called run all and test all. You're welcome to them. They are my test files written in Bash, in lovely Bash, yes. And they might not work exactly like you think. So I would look at the code before you rely on it, but it does some testing. I think the Autogen 3 is probably your best bet. There's some Autogen 2s as well hanging around from before. Oh, in old tests, there's Autogen and Autogen Plus. Why is it called Autogen 3 then? These are simpler versions written a million years ago, as you can see, 2012. And if you prefer to play with those, you can grab them from there. No, you can't. 1755 old tests. Right, or you can literally test it by hand. So let's go to an installation that works. Let's just turn this into something that looks the same. Open P1. So here's the test. See what happens if I run it. I don't know why this is so slow in starting up. Wow, that runs slow. Why is that? It's like a $3,500 machine. It can't even run a JavaScript. I bet a second time around. And let's try running it through Espresso CR. Oh, there's no such thing. So CP CS460 phase 1 espresso CR. Right. So here's manual testing. We do that. That's your compiler into me.txt and the reference compiler into u.txt, and then we say diff me.txt and u.txt, and it comes out with nothing. So if you produce the same output as the reference compiler, you may declare yourself the winner, at least, of that competition. Now, this is exactly what all these automated scripts do. They run all these tests for you and does all this diffing and tells you whatever might be wrong. So it just makes life a lot easier to deal with. Right. I will copy the video of phase 1 onto the current channel, but they are also available on. Well, no, they're just going to be on the YouTube channel. Yeah, and I believe that I still need to put up we still need to make a tar file of the notes from last semester and put up. I only did fall 2020, right? And if you look in the fall 2020 tar file, untar that, then the notes from the recorded lectures pertaining to the project are available there as well, if you, for whatever reason, would like those. But all the videos for the various phases are available on fall 2020 or spring 2021. It's the same video that we're going to use. I will just copy it over if I can remember how to do that, but we'll sort that out. So now it's open. You can do it. You can find yourself a partner, or you can choose to do it yourself. I was just about to ask that. You're way ahead of me here. When is the due date for this phase? How do we do polls in this thing? Polling. Right. Add a new question. So let me just put on my calendar here. Where are we today? 31st. So it's not Sunday. We shouldn't do Sunday. We should say. There you go. Can you see the poll? I don't know how this works. Oh. That's who? You don't understand democracy. It's the illusion that matters, right? This is how a dictator does this, right? So people cannot leave this and say, we were never allowed to vote on this. You were allowed to vote on it. Everybody was allowed. You could either vote or you could not vote, or, So.
Boycotting this vote.
Huh?
Someone said I'm boycotting this vote.
Well, you can boycott the vote, but the nice thing is that it has absolutely no effect because your vote doesn't count anyways, right? So that's just a waste of good energy, right?
Yeah, you can do a write-in. Just file it under your shredder, and we'll get right to it.
That's right. It's like trying to call the postal service in Denmark. You are number 123 in the queue. What the hell? You just opened. So here's the thing, right? We have how many weeks? 15, 14 left, right? And we got to squeeze this in. This phase is not a difficult phase, which is also why it's not worth a million points, right? So what I think we should do is get this out of the way, just so that we have more. I would much. How long should it take to complete this phase?
You can do it tonight, ideally.
I would say that if you are So if you're just sort of like doing it by hand and you're typing everything in, then a couple of hours, you know. But here's what I would do. There's a reason that I posted this in this format, right? You copy this in, you turn all those colons into colon equals. You remember to put a semicolon at the end. You replace all these single quoted things by the appropriate names from the token.java file. And if you're really clever and you know how to use sed, S-E-D, right? Then you can do some rather clever stuff with automatic replacement, but just be careful because colon appears there as well, and they should not be replaced by colon equal. So, but you would be silly not to copy this. And what I would actually do is I would copy it one section at a time and fix it. You can use sed or you can use AWK if you configure. I've never been good at AWK. I can sort of rock sed, you know, to a certain degree. But you know, copy them one at a time, and you can compile and you know, without filling it in, you might still get some error message saying that certain things are missing. But if you, I mean, here's an example, right? We'll take that. I'll take a copy of that. I'll go there. Oops. I'll just go back to there. Oops. There. Phase 1. That into grammar. Text. Put that in. D. Now, if I want to get a list of all left-hand sides, grep all rules that have a colon in, pipe that into cut or cut on colon, and I'll ask for field 1. Oops, and then I gotta say cat grammar into there. Oops, that should not be a redirect. That should be that. There we go. So of course there's that one here. Well, we'll just ignore that one, and we'll ignore these two. But all these other ones, we'll ignore that one. All these other ones are exactly the list of all the non-terminals. And if I wanted to, I could say sed search for colon replaced by colon equal globally in grammar. Oh, this polling thing is still going on. Democracy sure takes a long time. Maybe we have to put. Is it R for replace? Oh, you know, it's no semicolon first. There we go. There we go. See, colon equal. Now, of course, there's that one that shouldn't be colon equal here, which we've got to go in and fix by hand. But you know, it is certainly possible to do something clever here, right? As long as you make sure that you don't get too clever. Does Tuesday at midnight actually mean Tuesday at midnight, as in Monday is the last day to work on it? No, it's the night between Tuesday and Wednesday, because that means on Wednesday, on Tuesday next week we can release the next phase. Although, you know, with the videos, it really doesn't make that much of a difference, right? I really just want to get going on it, because if we're in a situation where we need a little bit longer, a couple of days here and there later on, then we can do it without any issues. We will make a hand in on. Oh, it's already made.
Just published.
Okay, he's way ahead of you. So hand in on Web Campus. Fortunately, CSGFMS is no longer with us. Yeah.
Git is okay so long as your repos are private.
Yes, please make them private. Okay, it's 18 after. We're supposed to have left a long time ago. Yeah, so we're going to leave. All right, I'm going to stop recording.